Hi, let's just solve this problem. Pause the video, read the question on your own, and try to implement the three steps. Okay, so let's just, if you have done it independently, good. You can check, or let's do it together. By principle of mathematical induction, prove that for all the positive integers means what are integers basically? All the negative numbers, 0 and the positive. So positive numbers start from 1, 2, 3. So positive integers means natural number only. Okay. So for all the positive integer, that means your natural number that is greater than 1. It means it is talking about natural numbers starting from 1. We need to prove this statement. Let's check the step 1 or the base case. Let us put n is equal to 1 on the LHS. What it gives us? 1, right? On the RHS, 1, 1 plus 1, 1 plus 2 over 6. That's basically 1 times 2 times 3 over 6, and that's basically 6 over 6. That's 1. So what it gives us? LHS is equal to RHS. So this implies our base case is true, or the initial case is true, n is equal to 1 holds. Now let us assume that it holds for n is equal to k. So step 2. 3, so on, k plus 1 over 2 is k plus 1, k plus 2 over 6. Let's just label it as star. Okay. We will be using assume part in the third step. Let's go ahead. Step 3. First of all, in the step 3, look, it's a proof question. We are proving it. So here steps matters. The way we write is matter. So first we'll declare, okay, what we are heading towards. So to prove n is equal to k plus 1 is true. So what do we get? What is the statement? 1, 3 plus k. Okay. So because we are doing it for k plus 1. So till k everything will be as it is, right? On the left hand side, what we are going to get? One more term. K plus 1, k plus 2 over 2. That's k plus 1, k plus 2, k plus 3 over 6. Okay, this is what we want to prove, right? The double star, that's our goal. So you need to declare. I have seen most of the students skipping this part and losing their marks. Losing their points. You need to write this, and then let's just start with the left hand side. So LHS. So you need to just rewrite it once again. So what is 1, 3, so on. K plus 1 over 2. K plus 1. K plus 2 over 2. Okay. So can you see till this spot it is same from the assume, right? So we will be using that. So we'll say from star or from this asterisk one. Okay, from this what we are getting is k plus 1 k plus 2 over 6 plus k plus 1 k plus 2 over 2. Okay. So now in the next step, let's just rearrange k plus 1 k plus 2. 6 is 2 times 3. You have k plus 1 over here. You have k plus 2 over here. And then there is a 2. Let's just pull out the common terms. So look, what we require k plus 1, k plus 2, k plus 3. So in the common part, you have k plus 1, k plus 1. I'll pull it out. K plus 2, it can be pulled out. 2 in the denominator can also be pulled out. Let's see what it gives us. So it's k plus 1, k plus 2 over 2. It's k over 3 plus 1, right? Now what it further gives us, let's take the LCM over here. Make the denominator same. So it's k over 3, 1 times 3. Here if it's 1, it means 1 over 1. Like 1 can be written as 1 over 1. Then I'm multiplying up and down by 3. That's what I'm doing over here. So hence I get this. So this gives me k plus 1, k plus 2 over 2 is k. This is 3. This is 3. Can I make the denominator same? Yeah. Now you have k plus 3 over 3 and here you have 2. Now let's just multiply the denominators and remove this square bracket. What it's going to give you? K plus 1, k plus 2, k plus 3 over 6 and hence this is equal to your RHS. So we can say that this gives us n is equal to k plus 1 is true, or some writes k plus 1 holds. It's up to you. So what we can conclude, principle of mathematical induction. Our given statement is true. What is given? For all, right? In the question, what is given to us? We will be using the same words. By principle, it for all integers n greater than 1. So we will be writing the same word. Oh, it's principle. I made a miss. It's true for all positive integers n greater than 1. So that's the required result. So yeah, that's it. Keep smiling, keep shining.